Hey guys, good evening, all of you. Welcome to Cheenta Statistics Analytics Department. And I have planned to do 3 problems today. I hope, due to the recent thunderstorms in Kolkata, I am not sure how much time I will be able to. The net will help me out, but I hope to give the best in my capability. So let's start, guys, and I hope everyone in the live too can hear me properly. I have plans to do 3 problems today. Tishika, I don't know if she's in the is she in the class? Tishika hasn't joined, but she has given 3 problems. She's not in the class. I will do some other problems. Okay. So let's do this problem. Okay, so this is an interesting problem. Actually, I was doing this this problem, discussing with about this problem in the some other classes. So let's start with the probability problem. Okay. It based on integration, sequence, and series, everything. So it's really interesting problem according to me. It like test everything that is there. Okay, my snipping tool is working now. Okay, and just give me a minute. I'm just copying the problem. Okay, here's a problem for you. The problem asks that. Okay, the problem asks that n is defined like this, that it's an integration from 0 to 1, 1 minus x square whole to the power n dx, and it asks to find the limit root n nth root of n, okay, is the limit, and also show that summation of accordingly show that summation of that diverges. So this is really important and this is really interesting actually. I will show you the ideas, but based on this problem, I will discuss certain interesting characteristics and properties of this integral. Okay, this integral is really known integral, which is known as beta integral. Okay, so in this live today, you will learn about something called beta integral. So what exactly is beta integral? Let's find it out. Beta integral. So what is this beta integral? So beta integral tells you that integration 0 to 1. So beta integral tells you that integration 0 to 1. Can someone tell me what is the beta integral? Anyone knows here? What is the beta integral, guys? So it tells you that so if you try to do this, this integral will be hard. Okay, so the idea is that beta integral, if you have done beta distribution in your continuous probability class, or may not do, you will learn this in your future classes, that this integral z to the power 1 minus n m into 1 minus z whole to the power 1 minus n dz is actually equal to beta m comma n. Okay. So z integration 0 to 1 z to the power 1 minus m into 1 minus z to the power 1 minus n dz is equal to beta m comma n. Okay. So the question revolves around the fact that like this integral. So let's try to understand. Let's try to do this integral in terms of like try to find the n in terms of this beta integral. So what is this beta? Beta m comma n is equal to, I think I am not doing any mistake, gamma m gamma n by gamma m plus n. Okay, I may do a mistake. Let's not be wrong. I will just search over the Google and I will just confirm it. Just give me a minute. So beta function is this. Oh, I did a mistake. As I can see, yes, I did a mistake. And the mistake is the following, that it's not m minus n. Let me write it properly. Yes, the beta integral is z to the power x minus 1 into 1 minus z to the power y minus 1 is equal to beta x comma y. Understand this, what is this x and y? X and y are real numbers greater than 0. Okay, and similarly it's over here that gamma x plus y. So let's discuss gamma x and gamma distribution some other day. But let's discuss beta distribution. I will not discuss the entire problem. I will discuss some ideas of it. Okay. Z to the power x minus. So this is a beta integral. Okay. And what is the definition of gamma x? I will be coming to it soon. Okay. So let's try to convert this integral into this integral. Okay. So our integral is in this case is what? Integration 0 to 1 minus x square whole to the power n dx. I hope it's correct. Yeah, for n greater than or equal to 1. So any ideas on how to convert this into a beta integral? Any ideas, guys? Any ideas how to convert this into a beta integral? What will you do? What do you think? Madhav, Mayur, Polash, Paulomi, Pratiksha, Priyam, Sriteja, Shuryang, Tanvi. Bolo. Any ideas on how to convert this? So you see there's a intent of going into 1 minus z. So do you think like z is equal to x square, putting z equal to x square seems to be a good idea? Yeah.
Sir,
Bolo.
we can. Sir.
Yeah. Go ahead. Yeah. Tell me.
Yes, sir. So we can write n as n plus 1 minus 1. We can express n as n plus 1 minus 1, and as you said, x square is equal to z, and then we can substitute x. Change the different integration signs dx.
Okay. So I think okay. So yeah. So let's try convert the x square to z, and let's see what comes out. So you get over here that 2x dx is equal to dz, right? And where it implies that x dx is equal to dz by 2 root z. This is what it's there. We can write because 2 root z, yeah. Because x is greater than 0, so root over z is greater than 0, so therefore root over z makes sense because greater than or equal to 0. So therefore this we get, and let's replace it down over here. So we get 1 minus z whole to the power n, and dz we get half, and z to the power half dz. Okay, so we have the condition x and y is greater than 0. So x minus 1 can be at most minus half. Okay, it's minus half over here. So this is possible. So let's try to write it down in terms of the beta integral. We get that it's half into 0 to 1. What we get? 1 minus z n plus 1 minus 1 into z to the power half minus 1 dz. So you get this is equal to half times beta n plus 1 comma half. Okay, all of you got this, guys? It's very easy. The integral value is not n. Shoham. All of you understood this? Any doubts? Okay, perfect. So this beta integral is really important because why I'm doing it to you, because when in the future when you will do the beta continuous distribution with us in the platinum course, then you will see that how it's important, these calculations. Okay, so that's why it's really interesting. Okay, coming back to this, so we have got the following. We have got the integral is turning out to be, let's say I has turned, oh sorry, it was an, I'm so sorry. N is turned out to be half into beta n plus 1 comma half. Okay, which in turn turns out to be half into gamma n plus 1 into gamma half by gamma n plus 3 by 2. Okay, so this actually beta integral is intimately related to the gamma integral. Yes, you're right, Devarshi. So it's intimately related to this gamma integral, so we will get that it's half. So there are some properties. I will not do this gamma function today. It's like something you should be knowing. Gamma half is equal to root pi. Okay. Gamma n is equal to n into gamma n minus 1. Rather, gamma x is equal to x into gamma x minus 1. for all real values of x, and sorry, x is greater than 0, I guess. And another property is there, gamma of any integer function is n minus 1 factorial. Okay, these are the three properties of gamma function. So I'm not going to tell you what is a gamma function as of now, but let's go into this. Like gamma function is related to two distributions, gamma distribution and chi-square distribution. You will learn later on. Okay. But let's take this as an assumption. We can take this as an assumption, and you can go ahead and calculate. So the main is the limit aspect. So you get over here n is an integer function over here. You can understand it's n is a natural number. So you get it's n factorial root pi. Okay, and this, the Nisha wala turns out to be a bit challenging, but we will deal with it. We know how to deal with challenges. So it's n into n plus 3. Okay, and then we will go into next n plus 3 into gamma n plus half. So we'll take n plus half into gamma n minus half. So we will continue like this. Since an integer, it will go till what? Half into gamma half. Okay, you can check it out. That maybe you can check it. You can pause this now, and you can check it out. That gamma, it's an exercise maybe. That gamma n plus 3 by 2 turns out to be n plus 3 by 2 into n plus half dot 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 half times gamma half. And you can see gamma half and root pi gets cancelled. Okay. So what we get over here is the following. That okay, all of you understood this, guys? I'm just giving some. My voice isn't clear.
Can you repeat how you simplified the denominator?
Yeah, I'm so sorry. My net is not okay then. I'm just sorry for this. Okay. Yeah, sure. I will explain it why it's. Oh, you're right. You're right. You're right. Actually, yeah, you're right, Deborshi. It's
Actually,
like
but
yeah, this will be this. Yeah, as I told, my net is not good today. You have to bear with it. Okay. Um. Yeah.
actually, but your voice is clear.
Can you hear now?
Yeah, it's absolutely clear.
Okay, I'm so sorry because as I told, due to thunderstorms and flashing, my internet provider has like told me like they cannot provide me the internet connection by before tomorrow, so I have to kind of somehow manage it with the mobile net. I'm really sorry for the troubles it's causing to you. Okay, if you can stop me if you don't understand. Okay, or if my voice gets blurred in the middle. Yeah, I'm really sorry for that. Okay, so these are the properties of gamma. Did you understand the properties of gamma, guys? Okay. So these are the properties of gamma. I made a mistake. Thanks, Devarshi, for correcting me. And we have got over here this that n factorial root pi. So we have got this. Okay, we have got this idea because of this first and the second, third result. And Nietzsche result, what I will do is I will break it down into this. For example, gamma n plus 3 by 2 by this result comes out to be n plus 3 by 2. Sorry, I think I'm doing some mistakes. N plus half into gamma n plus half. ठीक है, again you distribute gamma n plus half. Again, yeah, you're right. N minus half into gamma n minus half. And say n is an integer, right? So at some moment of time it will reach half. So at some point of time it will reach half into gamma half, right? So therefore gamma n plus n plus 3 by 2 is equal to n plus half into n minus half dot half into gamma half. Everything is replacing. So therefore this is the result you can like sort of understand. It's like just from this corollary. It's a corollary of this result. So we have got this equation. Okay, and gamma half cancel. So we have got that. Let me go to the next page. We have got that an is equal to half times n factorial by, rather I should write it in the middle, n factorial by n plus half into n minus half into dot 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 half 3/2 dot dot half. Okay, all of you with me, guys? All of you understanding, guys? Any doubts? Any doubts, guys? Okay, perfect. Okay, so here are some questions I should tell you. It's asked that to find an whole to the power 1 by n ka limit. Okay, it's asked to find a summation of n from 1 to infinity. These two things they have asked. Okay, now understand this very carefully. When these two things are asked, then first we need to find n whole to the power 1 by n. Okay, so let's try to find out that value. So there's something called Cauchy's second theorem, but I will not use that. I will use other methods to make you understand that. Okay, let's see if we can use other methods to make you understand that. Or let's see. Okay. So they have asked to find an whole to the power 1 by n. So let's try to understand what is an whole to the power 1 by n is. So for this, when you do an whole to the power 1 by n, I will do bits and pieces of it. Okay. So you will get that it's equal to 1 by, so it's turning out this n factor whole to the power 1 by n fact. This is turning out once. Okay. Or let me check if I'm missing something. Okay, let's write it down in a generalized format. So you see, it can be written down as 1 n factorial by 2n plus 1 into 2n minus 1 dot 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 3.1 into 2 to the power क्या होगा into half है यहाँ, and that will become क्या होगा 1. So okay, so it will become 1. There are how many terms? 1, 2, 2n minus n plus 1. So it will be 2 to the power n plus 1 by 2 hai, so it will get cancelled and we will get 2 to the power n over here. Okay, that is what we will get over here. And understand, if we multiply now this interesting thing, let's see what is this interesting thing. 2. Okay, let's understand, we'll multiply these numbers now. 2 here, the even numbers 2, 4, okay, dot dot till 2n. So what we'll get? We'll get 2 to the power, how many numbers are there? 2 to the power n into n factorial. Did you understand that 2 into 4 into 6 dot dot into 2n is same as 2 to the power, is same as what? 2 into 1 into 2 into 2. Okay, so for each one of them, if you take out 2, you get 2 to the power n into 1 into 2 into 3 into dot n, that is n factorial. So therefore this you get, all of you got this, guys. This is a very interesting idea. Did you get this idea, guys? This is interesting calculation actually. All of you got this idea? Got this calculation? Any doubts?
Sir, can you repeat, sir?
Which part? Tell me.
The last part, sir.
Okay. So I'm telling you, so did you understand till the red part?
Yes, sir. Yes, sir.
Did you understand till this portion? The last calculation is the following. I am multiplying. So I wanted to make into a complete factorial. So for that I need to multiply what? 2, 4, right? To make it a complete factorial, right? Till 2n. Did you understand this, Madhav?
Yes, sir. Yes.
So therefore here, if you multiply it by, similarly we'll multiply it above with 2n into dot 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 till 2. So what we'll get over here? We'll get n factorial into, like नीचे होगा 2n plus 1 factorial, ठीक है? ऊपर होगा 2 to the power n into, now understand, you take out 2 out of each one of them, 2, 4, 6, सबसे 2 लेके out, take out 2 out of that, so you get 2 into 1 into 2 into 2 into 2 into 3. Now out of this n terms, there are two n 2's, and on the other hand side, like if you see it as 2 into 1 into 2 into 2 into 2 into 3, so till into 2 into n, all these numbers are like this. So if you multiply, you get 2 to the power n times n factorial, right? If you take this, it's 2 to the power n times n factorial. So you get into 2 to the power n times n factorial. So what you get over here? You get that. Did you understand now, Madhav?
Yes, sir. Clear, sir. Thank you.
Okay. So you get 4 to the power n into like by, if you see it's n, so what you do is that you take 2n out, 2n plus 1 outside, and you take 2n choose n. Okay. So all of you agreed with me that we have got this equation that n is equal to 4 to the power n into 1 by 2 to the power n 2n plus 1 into 1 by 2n choose n. We have got this, guys. Did you get this? All of you agreeing with me? Did you understand we have got this? Any doubts in this derivation? Any doubts in this derivation, guys? Half is remaining. Half kahan chala gaya? No, there is a half over here. See, this half. So it was actually 2 to the power n. It was multiplied by 2 to the power n. Okay. So this niche wala 2, it went above. Na? It was 2 to the power n plus 1. And this half was there. It got cancelled to get 2 to the power n. I have mentioned that. Mayur. Yes. So we have got this entire an is equal to this. Okay. So yesterday, maybe I didn't give a question to all of you. I gave a question to like okay. Anyways, yesterday, so I maybe have discussed. I don't know if you have been a part of it. So yesterday we have discussing this question. So we have got this an is equal to 4 to the power n into 1 by 2n plus 1 into 1 by 2n choose n. So now if you do a whole to the power 1 by n, you get by n whole to the power 1 by n whole to the power 1 by n. Now you want to make limit n tends to infinity. So you get it's same as 4 into limit n tends to infinity 1 by 2n plus 1 whole to the power 1 by n into limit n tends to infinity 1 by 2n choose this. Okay. So we have got these 4 limits. So therefore we have to individually find out this limits. 4 is a limit, so we have to individually find out limit n tends to infinity 2n plus 1 whole to the power 1 by n. Okay. And or एक limit n tends to infinity 2n choose n whole to the power 1 by n. These are the limits you need to find out. Okay. These are the limits we need to find out now to complete the whole problem. Everything clear till this point of time, guys? Any doubts? Any doubts? Okay, perfect. Okay, so let's move ahead to the next part. So how do you think you will do this type of problem? I discussed in the class actually that how do you do this type of problems? So I will start with a few problems like this that I will give you certain homeworks, okay? Because I will do another problem. I will give you certain homeworks. I will discuss this in the class, other class. So 2n plus 1 whole to the power 1 by n it came. And so we are asked to find limit n tends to infinity 2n choose n whole to the power 1 by n. So how do you find this kind of limit? First one bolo. How do you find first one ka limit? Bolo. Any ideas? How do you find first one ka limit? It's of the form what? It's of the form infinity to the power 0. So how do you deal with this? I've given you a chart, right? How to deal with this usually. Infinity to the power 0, how do you manage it? Any ideas? Okay. So tell me this thing. So let's do this limit. So I mean, I will give you this homework. Okay, I will not discuss this now. What is this limit? What is this limit? Anyone? What is n to the power 1 by n ka limit? Tell me. So there are various limits which are really important. Log and expand. You take one to log and expand. Okay. You want to take log and expand. Okay, that's a good idea. Let's check it out. So if you want to take L is equal to limit n tends to infinity to n plus 1 into whole to the power 1 by n. So if you take a log of L, you get limit 1 by n into log n plus 1, n tends to infinity. How do you do this now? How do you do this now? So you can sort of make an idea that, okay, can you tell me what is this limit? What is this limit? Can you tell me, guys? What are these two limits? Tell me. N to the power 1 by n, what is that limit? What is the limit of n to the power 1 by n? 1. So how do you prove it? So okay, so you can use the same idea. You can show it from here by using L'Hopital and first you need to explain it to continuous case. Use L'Hopital, and then you come back to this because every subsequence will have a Unix limit. Okay. So I will just ask you and give you the small hints. Okay. So limit n tends to infinity, n to the power 1 by n is 1. So you can use this idea over here. Limit n tends to infinity 2n plus 1 whole to the power 2n plus 1 is actually order of, like, it's BF like what? You can do it like this. It's 2n plus 1 by 2n. Okay. Or maybe you can do like this. You can do the same interesting idea. Or maybe you can divide by 2n. Okay, let's divide by 2n. So you get 1 plus 1 by 2n whole to the power 1 by n. Okay. Or maybe you can do like this. Let's check it out. What we can do. I was thinking of doing like this. Into 2n whole to the power 1 by n. Show that it's actually going to 1 again. Okay. Because it is sort of behaving like 2n whole to the power 1 by n. And this is actually equivalent to 2 to the power 1 by n, 10 to the power 1 by n, which is behaving like 1. So I'm just giving you the opportunity to like prove it at home rigorously. Like it's not rigorous over here. Okay. That's why I'm giving the opportunity to prove it rigorously when you at your home. So therefore you will get that this is actually equal to 1. Here, if you do that, you will see it's this log. If you take L'Hopital, you will take it by double differentiating it. It will turn out to be 1 by x form, 1 by n format, which will be going to 0. So log L will be 0, L will be 1 over there. That's fine. So this is the idea. Okay. And this is a really interesting problem I was discussing last day. And you can find out this limit is equal to 4 somehow. So this I will give you as another homework. Okay. Those who have not done, those who have done this problem, it's okay. Then you can you know how to do it. So therefore we got these three equations, and what we get over here. Therefore we get over here that this equal to therefore is 4 into 1 into some epsilon, which in some L dash, you like it's something positive. It exists. So we get this limit as this. Okay. So now tell me this, that with the limit. So therefore, can you tell me now whether summation of an exists or not? So now tell me whether summation of n tends to, or also you can tell it from here. Just okay. So tell me now, a summation of n, will it what will be the limit? What will be the limit of this series? Any ideas? You understood the behavior of an, right? You have understood the behavior of an. N is this. Okay, n is this. I've written down over here. You understand the behavior of an. So tell me how an will behave as n goes to infinity. You can also understand from here. An behaves like this. So find it out. This is really interesting. Okay. So show that this limit is not going to 0. This limit is going to something positive. Okay, I'm giving you hints and ideas. This limit is going to something positive. How we get 4 to the power n over here? I have discussed it already Priyansh a lot time back. 2 to the power n एक यहाँ से नीचे से और एक 2 to the power n from this. It's a lot of like you should go back and see the recording. Okay, we have already got this from like lot ahead, and yeah, so you show that this is not going to 0. Okay, and hence this summation, this will be divergent. Okay, so these are the ideas I am giving you. So you should try 2 to the power 2n, isn't it 4 to the power n? Priyansh? Okay, so I think it's 4 to the power n. You can just revise your exponential results. Yeah, so therefore these are basic ideas, these are basic hints I am giving you today, and you should go back to your home and you should try out these problems yourself. The small problems I have given you now. Okay, in this slides over here, mainly in this slide, all the small problems I have given you. So you can try this out, and this is really interesting topics, and you should try out this small results. Perfect. So any doubts till this point of time? Otherwise I will move on to a different problem with its ideas. You can try out this problems now. You have got the hints, you have got the steps now, I hope. Okay. These are the problems that can come in ISI MStat. So that's why I'm discussing this just before the ISI MStat, if the 2021 people are here. Otherwise, they are like the 2022 people are getting prepared for it since they've already done real analysis. Okay, any doubts, guys? Otherwise, I'll move to the next linear algebra problem. Palash, Polami, Mayur, Pratiksha, Priyansh, Sriteja, Tanvi. Any doubts? Okay, perfect. Perfect. So please try out the problems. Okay, I have given you the hints. Otherwise, it will not be complete. I really want you to try out the hints apart from the homework problems that we have given in the class. I mean, in the classroom on Monday batch. Okay, so let's move on to a different problem now. So try out these hints. This is a must. Try out the hints. This is a must. Okay. Polomi, are you understanding? Okay. Perfect. So let's do this problem. Okay. So this problem is that if P is an n cross n non-singular matrix such that 1 plus P square plus order P to the power n is a null matrix, then find the inverse of P and the eigenvalues of P. Okay? How will you find this? Any ideas? How will you find this? Any ideas how will you find this? How will you approach this problem? These problems are some problem that really goes into the basics of yours. So how do you find the inverse of P? Yeah, so seeing this equation, seeing this weird stuff, 1 plus P plus P square, this stuff, does anything do anything come to your mind, guys? Does anything come to your mind? Seeing this weird equation, does anything come to your mind? This stuff. Anything? Tell me. Seeing this 1 plus P square plus order P to the power m, something comes to your mind? I'm sure something must be coming to your mind. Bolo?
I'm not sure. 1 plus x square. So we can compress it, sir.
Yeah.
Factorize it.
Into complex numbers, but here you're right, it's a geometric sum. So what is the so what is, like, how can I do it for the matrix? There is some equivalent result for the matrix actually. Same geometric matrix equivalent result is there. Same. Same. Can you tell me? Any ideas? Okay, I will tell you. So understand, this is a really interesting idea. If you do 1 minus, so this is a corresponding for the real numbers ke liye this happens. So there is no concept of like x by y in matrix. So we need to do it in everything in matrix multiplication format. So you get that this is equal to 1 minus x to the power n plus 1, right? This was the result. Similarly, if you can show this, that for matrix multiplication, I minus p, just similar calculation, okay? Just because p to the power m into p to the power n is equal to p to the power m plus n. Okay, it's actually commutative in some sense. This multiplication in in mathematical terms. So it's actually the same result holds. Anyway, it's not going to too much of mathematical terminologies. So therefore, this turns out to be. Can you guess what it will turn out to be? I minus nothing. Yes. Good. I minus put to the n plus 1. That's very intuitive. This is down, and you can really easily prove it, okay? Just by taking, you will see telescopic something is coming up and alternate terms are getting cancelled. It's very simple. So let's try it out. So we'll get that. So this is what we have got now. Now this is equal to 0. So understand my thought process. I'm giving you the theory. I'm thinking about the problem. From this, we have got an idea as geometric sum, and we are trying to connect it to linear algebra. You see the thought process. So always when you're solving a new problem, always you connect to the previous knowledge you have, okay? Then you try to get some similar idea over here. That's how human minds work. That's how you should think about a problem. That's how you should develop your problem solving skill. Okay? Exactly, that is the idea. And that's where you will get that it's equal to 0, because that's is equal to null matrix over here. So you will get what? You will get p to the power n plus 1 is equal to I. It's nothing very interesting idea, but if it asks you that find the inverse of p, so can you find the inverse of p from this interesting information? Can you find the inverse of P from here, guys? Can you find the inverse of P from here? P to the power n plus 1 is equal to I. So can you find the inverse of P from here? Perfect. So P to the power n times P is equal to I. So you get that P inverse, since it's unique, it must be equal to P to the power n. So we have got this. Superb. Superb. So now how do you find the eigenvalues of P? So yes, so understand, we didn't actually try to find P, understand the logic, understand the problem solving steps I used, okay? Because you need to be like understand how I thought about the problem. I saw the equation 1 plus P square plus P to the power m. Usse it came to my mind that okay, I've seen something somewhere in my life, in my mathematical career or student life, is that I've seen the geometric sum. I tried to connect it to the linear algebraic aspect. I got this result. Okay, that 1 minus P, this is where the creativity comes. You have to think about how it can do it. And 1 minus P into this comes up. And we use the information given over here, and we got that P to the power n plus 1 is equal to I. So not always you will think about going towards solving the whatever it's required to find, okay? Sometimes you have to understand the like the symmetry of the problems or the equations, and then see what happens, and then automatically things will turn out to be good, okay? That's how the problem was made. So that's how you should approach the problem. And so you get that from there, you get P to the power n is the inverse, okay, of P. The next part comes up and asks you that what are the eigenvalues of P. If it's asked you what are the eigenvalues of P, so what should you do first? Tell me, what should you do first? What should you do first, guys? If you ask about the eigenvalues of P, what should you do first? Tell me. It's very easy. Bolo. Bolo.
So we can make use of the property.
What property?
Sum of the eigenvalues is equal to. Sir, I'm not sure about it, but the sum of the eigenvalue will be equal to the det of P.
No. The sum of the eigenvalues is equal to trace of the matrix. But here, no. Wait. Here, no information is given about trace of the matrix. So why will you approach that? You understand? It may be a good approach, but my question is that there is no information about trace. So why you have no way of opportunity to use the data of trace you have, the result you have. So it's not a good like optimum way to approach that problem. You understand, Mayur? Madhav, sorry. You understand? There's no information given about trace, so you also need a determinant of the matrix. Yeah, in fact, it's given determinant of the matrix can be 1, but from there you get the product. But here you have to find the individual perfect characteristic equation. So therefore, when it's asked to find the final, yeah, you're right, Deboshi. Eigenvalue of P is 1. Let's check it out. Bhushan, it's not told that eigenvalues of P have to be real. Okay, it's not told. So they can be complex numbers too. So let's check it out. So whenever people ask you to do eigenvalues, find out the eigenvalues, you can do it in 2 ways. Okay, since you have some property, you can just go by the definition of the eigenvalue, that P of V is equal to lambda V for a vector V. Let's V the eigenvector. Or you can use the determinant format. P minus X, P minus lambda I, iska determinant is equal to 0. Okay. So you can use this idea or this idea, any one of the ideas. And from here you will get what? From here you will get NF of lambda of degree n. It's Pn, right? P to the power Pn cross n of degree n is equal to 0. This is what you will get, a polynomial in lambda. This is what the Cayley-Hamilton theorem is. Okay. And it's a unique polynomial. You must understand it's a unique polynomial. With and up to constants, I mean. So it's a unique polynomial. So we will use this property, it's a unique polynomial, okay? Understand that here, can you use this idea that P minus lambda, is it really easily available to understand? Here P to the power n plus 1 is equal to 1, I is given, or this question is given. So I am not directly, I didn't see, maybe you will find, I didn't see any direct application or like direct easy way to find out this determinant, okay? So I didn't find out, you may find out. So I didn't find out any easy way to use the information. See, I am telling you the way I am thinking, okay? It may not be the only one, but I'm giving you the other ways you can also think, okay? That's very important so that you can explore your own ways. I don't see any connection to the given information. So I didn't take this approach, okay? Rather, I took this approach, but I later connected it to this. I will show you how. So as I talked about this, there is some results that if lambda is an eigenvalue of p, then if you just apply p square again, now let's see p square, so you will see that it becomes pv is equal to lambda square v. You will see it. Pv will be lambda pv, and pv is again lambda v, so it's lambda square v. So you will get that p to the power n is equal to lambda to the power p to the power n v is equal to lambda to the power n v. So this is a very interesting property. Okay, so what is the property? I will write it down again. The property is the following: that if PV is equal to lambda v, then you get that p to the power n v vector is equal to lambda to the power n v vector for all natural numbers greater than or equal to 1. So this is a really interesting property. So you get that from here. So let's try to understand this. So now 1 plus p square, this is equal to 0, right? But let's try to understand the eigen like this of vector 1 vector v. So this vector v gives that this is equal to what? V vector plus pv vector plus p square v vector dot dot plus p to the power n v vector. From this equation we get that v is an eigenvector of p, okay? From this you get that v, 1 plus lambda square plus dot lambda to the power n v. Now you know this is equal to 0, right? Even if v is non-zero. So a scalar times v, a non-zero vector, is 0 vector. So therefore it implies that the scalar must be equal to 0. So you get that 1 plus lambda square plus lambda to the power n is 0. Now understand, what does the Cayley-Hamilton theorem say? Cayley-Hamilton theorem says that there is an unique f of lambda n, like a polynomial m, such that is equal to 0. Okay, whose roots are the n eigenvalues. Maybe some of them can be equal, but n eigenvalues. This is what Cayley-Hamilton theorem says. Reference Cayley-Hamilton theorem. Try to understand the way I am thinking so that you can understand, go in the same way, okay, in your own way. So therefore we get that this must be equal to p minus lambda I determinant. This must be equal to that. So we get that the eigenvalues are the root of this equation. So can you tell me what are the roots of this equation now, guys? Can you tell me what are the roots of this equation now? Lambda is not equal to 1. It is not a solution. You're seeing that yes. So root of this equation are the nth roots of unity that you have learned in your college, in your school. N plus 1th roots of unity. N plus 1th roots of unity. Excluding 1. You will see 1 is not a solution of this actually. And yeah, that's it. 1 is not a solution of this. So I will tell you one mistake I did, okay? So that you understand that what are the mistakes you can do. I will tell you one mistake I did it when I tried to solve this problem initially. So one of the mistakes I did is over here. One of the mistakes I did is that I got this equation right. I assume that P lambda is equal to P V vector is equal to lambda V vector, and therefore we know P to the power n plus 1 V vector is equal to lambda to the power n V vector. So we know that P to the power n is equal to I, so it must be equal to V vector. So therefore we get that lambda to the power n is n plus 1 is 1. Okay, this is what we will get. And you can think that okay, then lambda must be equal to 1. That no, it's not true. Two things are there. Lambda can be complex numbers, and the equation of lambda, understand this is nth plus 1 degree equation. It's an extra, you're including an extraneous root, it's called, that is equal to 1. So it can make you think that lambda is equal to 1 is a solution. In fact, lambda is equal to 1 is not a solution. You can prove it from here. Why lambda is equal to 1 is not a solution? If you take lambda is equal to 1 a solution, then if you do p vector with this, v is the corresponding v vector for lambda is equal to 1. So you will get that sum of v vectors. So if lambda is equal to 1 is a solution, then the exists w vector is equal to this. And if you multiply with all of this, you will get what? You will get that n plus 1 is equal to 0, which is not possible. You will see it will get this, which is not possible. Hence lambda is equal to 1 is not a solution. You are getting this here because you're introducing an extraneous root by multiplying this with here. This is the basic mathematics that is going behind the screen. Yeah. So I'm telling you my mistakes because so that you can understand what can you do wrong and why it's logically wrong. It's okay to do mistakes, but you have to learn from that. Okay, I even do a mistake, I learn from it. I tell it to my students. Sure. Okay, so you understand that it's nth root of unity, and or do you want to explain why 1 is not a root eigenvalue?
Yeah, I want to know why.
Did you understand this, that it can be eigenvalue? It feels like it's an eigenvalue from here, but it's not an eigenvalue. Okay, so I will do the proof for you. So proof is very simple. Let's say 1 is an eigenvalue. So there exist v vectors as that p vector is equal to p w is equal to w, right? It was Tanvi, right? Yeah, p w is equal to w, right? So understand now that 1 plus p square dot p to the power n w vector is what? W vector plus w vector plus w vector dot w vector n plus 1 times, and this is equal to 0, you know, so it must be equal to 0. So what you get? That n plus 1 w vector is equal to 0, and w is not equal to 0. Okay, because it's an eigenvector vector you're taking, series vector. So it turns out n plus 1 is equal to 0. Yeah. And understand why it's coming out. Why is 1 coming out to be a new root? Understand, because it's very simple. Because this is coming out just because you're putting p is equal to I over here. Just like x is equal to 1, you're putting an extra value is coming up. Now x is equal to 1 is the solution of this new equation. Similarly, it's coming up here that lambda maybe is equal to 1 is a solution, but it is not. You're putting in this 1 minus x extra, that's why it's turning out here. Okay, that's exactly the reason. It's called extraneous root. Okay, so it's okay to do mistakes, but it's okay to better to learn from them. Okay, so this is a basic idea and basic problem I have in my mind. So did you understand the two problems I did today? Okay, perfect. So let's see if I have a time to do some other problem. Um, Okay, let's do a probability problem as I have promised. Let's see. Do I have some probability problem with me? Doesn't seem like so. Just give me a minute. I'm just finding a probability problem for you. Okay, Tishika send me a problem. Let's discuss that. I don't know if I will be able to do it right in front of now, but I will just try. What is there to try? Okay, so let's do this probability problem. So the probability problem tells you the following. Each of n turns contains A white and B black balls. The two components A and B. A and B. A and B. And it continues. Okay, this is an interesting problem. I like this problem. So randomly a ball is taken out from here and transferred to the second. And then a ball is taken out from here and transferred to the second, the third. And then a ball is taken out from randomly and transferred to the next one. And it continues. What is the probability the last ball is white? And then a final ball is taken out. What is the probability it's white or black? Really interesting problem, real life problem. So let's try it out, guys. Let's try it out. Okay, so you can understand it from here something that the number of balls, like it's conditioned in the previous one. Okay, it is conditioned on the previous one. So what I will do is that I will do it for two cases, like for two. No, so understand something. This Pn is dependent upon this Pn minus 1. Okay, you understand? This Pn is dependent upon Pn minus 1. It's like a chain. So this demands you. So understand, this just dependent upon the previous box or not the previous one. Just the Pn minus 1. This probability of white depends upon the probability of white of this. It just because you know that here will be A plus B plus 1 balls. So you know how many balls are there. So how many whites and how many black, and that depends upon this. So therefore you know that this is what it can be. So therefore you can understand that it just depends on the previous ball, the previous box. This is the first thought that came to my mind right now, and that's why I'm telling you. So as I told, I always focus on this diagram of conditional. So I can understand this is dependent upon this. That's what came to my mind. I have told you yesterday also. Oh no, not yesterday. It was a senior batch. Okay. So always all this tree diagram and stuff. So the first idea is that the central idea is that Pn is the probability of white from the nth box. So Pn is dependent upon Pn minus 1. Okay, so that we will understand the relationship. To understand this, that Pn minus 1 jab hai, we know the Pn minus 1 value. Okay, so at that point of time, let's say Pn minus 1 is the probability of the being white, and there are A plus B plus 1 balls. So now a ball is taken and added here to here. So it can take two cases. So from n minus 1th box, understand the diagram I'm drawing. It's very important. This is called a tree diagram. N minus 1th box, it can happen that you have picked out a white ball or you have picked out a black ball. Okay, you picked out a white ball with Pn minus 1 probability and 1 minus Pn minus 1 probability. If it goes here into the new box, then that single, so what happens? There are now A white and B plus 1 black. And if this goes, you have A plus 1 white and B black. I hope that was the yes, B blacks. Perfect. Right? All of you understood this step, guys? All of you understood this step? Yes. Yes, yes. Okay, good. Perfect. So now when you take out a ball from here, the probability of white given W from, so probability of white now turns out to be what? So this probability, as I told, this is probability of W given W n minus 1. That is, the n minus 1 ball is white. Like you have picked out a white from n minus 1. Now here, probability of W given Bn minus 1. Like if you have taken the black ball from the n minus 1th box. This is equal to what? This is equal to A plus 1 by A plus B plus 1. And here it's equal to A by A plus B plus 1. How to write it mathematically now? Probabilistically. Let's see it. Yeah, bolo.
So can you explain quickly again, sir? Like, I'm lost with the PN, sir.
Yeah, Pn is the probability that it's the white ball. So let's say the experiment stopped over here, okay? Then that is Pn minus 1. So Pn minus 1 is the probability that the ball is white. You pick up a ball that is white. That is the probability of Pn minus 1. Okay. So now understand that from this n minus 1th box, you're picking up a white ball and you're transferring it to this. Then it the probability of the white ball will be a plus 1 and into a plus by A plus B plus 1, because there are A plus 1 white balls and B black balls. If we have picked out a black ball and transferred over here, the white ball will be, probability of white ball will be A by A plus B plus 1. So understand, I'm writing it again. You will understand it more better now, I hope, if you are good with understanding probability. So understand, probability white from nth box is same as probability white from nth box given white from n minus 1th box to nth box into probability of white from n minus 1 to nth box plus probability of white from nth box given black is transferred from n minus 1th box to nth box into probability black is transferred from n minus 1th box to nth box. Now let's find out individual probability. So this probability we know that given that white is transformed from this, there are A plus 1 white. So it's A plus 1 by A plus B plus 1. This here is A by A plus B plus 1. This here is probability the white is being transferred n minus 1th box to nth box is Pn minus 1. And here it's 1 minus Pn minus 1. So what you got over here? You got that therefore this is Pn is equal to Pn minus 1 times A plus B, A plus 1 by A plus B plus 1 into 1 minus Pn minus 1 into A by A plus B plus 1. So you will get that Pn is equal to A by A plus B plus 1 plus Pn minus 1 by, you will see it will minus is A plus B plus 1. So you will get that Pn is equal to some constant plus, you can do it like this, some alpha into Pn minus 1 plus beta. Okay. And let's understand P1. P1 is what? Initial one. It's A by A plus B. Okay. So you have to solve this following recurrence relation. Therefore, that P1 is equal to A by A plus B, and Pn is equal to some alpha plus beta Pn minus 1. Where alpha is equal to A by A plus B plus 1, and beta is equal to 1 by A plus B plus 1. And you find out in terms of Pn int, you will find out Pn int as a function of alpha and beta, and you put it over here and you will get Pn. So you see the thought process. The thought process revolves around the fact that nth box is actually dependent upon the n minus 1th box. That's it. All of you understood it, guys?
Can I show the previous slide from previous slide?
Sure. Which part?
The green parts are down.
Yeah. Okay, all of you understood it? Any doubts, guys? So this is how you think about conditional probability. This is very important, okay? I have given some problems in the mock, like in the exam this month, okay? Exactly, depend on the previous box. The rest are just depend on the last box. That's how the experiment is done, okay? That's the basic idea. In fact, it depends upon the previous boxes, okay? But once you know the n minus 1th box, then it forgets the past. This is actually sort of the idea of Markov chain, okay? Like which you will learn in stochastic process classes. But the idea is that if you know the details about the n minus 1th box, it doesn't require the n and the previous boxes knowledge, okay? You just know that. That will be the enough. That's the basic idea. That's how you understand the problem and start with the problem. And that's how you start about conditional probability. You think about what is the relationship between the random variables and the experiment and stuff. Okay, guys. So I hope you enjoyed the session. And okay, so I will see you in the next session. I hope you enjoyed that. If you like the session, please do share it with your friends and do subscribe to our channel for this Thursday, every Thursday webinar. Okay. And I hope you enjoyed it, and yep, do give a like and share it with your friends and comment and subscribe. Okay, bye bye guys, and I will see you in the next live session. Bye.